Welcome to the Ash Cloud. I'm Ash Sweeting. The amount of grass a cow takes to produce a cow each year varies hugely and is the key driver of farm profitability in most grazing operations. Yet, despite the importance for this from an environmental sustainability and a farm profitability perspective, it remains one of the biggest grey areas and least known areas of livestock production. Today I'm joined by Matt Wilso from West Virginia University, who has spent his career studying how efficiently cows turn grass into food. Matt, thank you very much for joining me today.
Sure thing. Glad to be here.
So the work you're doing on, understanding the inputs into livestock production and how that impacts the viability and profitability of the farmers and ranchers you're working with, as well as their sustainability and environmental climate footprint. Can you please elaborate and share with me what you're focusing on in that space?
Sure. So the work I've been doing the last number of years has started and revolved around work at our central performance test. So we've got a bull test in the eastern portion of the state. And in 2003, we installed what at the time was a GrowSafe feed intake system so that we could start to collect data on individual feed intake in animals that were in that performance test, and then research animals that we put through that facility as well. So that happened in 2003. We were actually the very first central performance test in the US to have an intake system. We installed that in August of 2003. Monty Curley at the University of Missouri had installed a research system in April of that year. So we were really kind of at the leading edge of individual intake systems at the time. And the focus very quickly turned to trying to not only measure the traits that we would normally measure in a bull test, but to also determine individual feed efficiency for those animals. We use residual feed intake as the measure of feed efficiency. There are a couple different ways out there that people use. The advantage to that is it focuses mostly on maintenance energy efficiency, less on growth efficiency. And so it gets at the huge, the preponderant energy demand of the animal is for maintenance. And so that was really what we were focused on. And then in 2019, we added to that system the ability to get individual body weights on animals when they went to water by installing in-pen weighing nodes. And when we did that, we convinced GrowSafe, which is now Vitelli, to add meters to the waterers that we used as an attractant for those in-pen scales, and integrated that water intake information into the system as well. And so for the last 6.5, 7 years, we've been collecting individual daily feed intake, water intake, and weight data on animals. And my focus these recent years has really been about taking that wealth of data. We'll evaluate between 600 and 900 animals a year in that system, and taking that wealth of daily data and trying to use it to build sort of machine learning or AI based approaches to determine intakes of grazing animals. And there's a huge need in the industry to have tools that could work at scale and accurately measure dry matter intake of grazing animals. Until the tool we developed, a lot of that was based on equations in the nutrient requirements of beef cattle manual. The equations are based largely on dry lot data. And we took the time and the effort, and it was a significant effort in time, and both in the field and in the laboratory for the graduate students, to go through and do a lot of ground truth data collection by using inert markers of animals that were grazing out on pasture to calculate individual intakes. And so we built a tool that allows us with daily body weight and daily water intake, and then we scrape publicly available data from the nearest NOAA station and metadata about the animals we're evaluating and are able to determine individual dry matter intakes. And so that's been a huge benefit to get that kind of data, accurate data about animals that are actually grazing in the field.
And for people who are not animal scientists, the why is this so important?
Well, it's critical because as we talk about footprints of the beef industry, whether that's carbon footprints or water footprints or ecological footprints, there's about 90 million beef cattle in the US. Um, about 12% of them are in a feedlot, for the final stage of their production. But the majority of them, the other 88% are grazing on pastures or eating harvested forages. And so knowing what those animals are actually doing is important, especially as we think about things like greenhouse gas emissions as an example. So the methane that an animal um, adds to the environment, mostly through um, the rumination process, it's about, the book says it's about 23 grams per kilogram of dry matter intake for animals that are eating a forage-based diet, about 10 to 13 grams per kilogram of dry matter intake for animals that are in the feedlot. And so the grazing animal produces about twice as much methane per kilogram of dry matter intake. And it's where 88% of the animals are. And, the US, it's 88%. Around the globe, the numbers of animals that are fed in a feedlot is even lower. And so, the overwhelming number of ruminants around the globe are in some sort of pastoral grassland system. And one of the features of that is that's where their their methane intensity is the greatest. And so understanding what's really going on there is critical for us then to identify animals that are more efficient in resource utilization and to make improvements then in those footprints, of a variety of types, um, in those animals, because that kind of change, genetic change in their resource utilization, is permanent and additive, where feed additives that might reduce out some of those outputs and shift some of that carbon to energetics of the animal. Those really only work in situations where you're formulating a ration and delivering it to the animal.
A lot of great stuff there, but to take a little step back, in terms of going through some of the things you said, you mentioned the maintenance requirement and the growth requirement. So any animal, depending on its size and its genetics and a bunch of things, will take a certain amount of energy just to stay alive, for its normal metabolic functions before it actually grows and produces any food, be that beef or meat or milk. And so if you have an animal that is only being fed at maintenance, you're keeping that animal alive, but you're not actually producing any food. So um, its impact, the relative merit of what it's creating for society in terms of food and the cost of that in terms of economics as well as environmental impact, it's not creating any value, but it's still got a significant cost. So that's a big part of why this efficiency is important. And I frequently think about this a bit like cars or vehicles. And if you've got 10 gallons or what 40 odd liters of fuel, you can stick that into an efficient vehicle and drive 300 or 400 kilometers, or you can stick it into a very inefficient vehicle, create much more pollution and not get very far. So it's a energetics is a similar concept in that regard. Is that how you see it as well? Does that make sense?
Absolutely. So, a big the what we feed animals is really their fuel. It is really an equivalent to the liquid fuels we would use in a vehicle. And so I actually have a slide I often show in presentations I give where we had two bulls that were in our one of our performance tests that were very similar in genetics. So they had the same sire. They were born to half sib cows, born just a day apart from each other. And in our performance tests, they gained the same rate of gain, but one of those animals ate 50% more than the other for no additional performance. And if you put that difference on an annual scale, it was uh, almost 7,000 pounds of additional feed intake for no additional performance. It was like the difference between a car from the 70s with a carburetor and a car from the 2020s with fuel injection. It's just that different. And the reason we focus on the efficiency of maintenance is because you're right. But depending on the life stage of that animal, it's 75 to 90% of their energy daily is used just in maintenance. It's why if I go to the gym for 15 minutes, I don't lose much weight because most of the calories I take in are used just to keep me alive. And in order to burn excess calories, that the number of calories I need to burn is tremendous because it's really a small increment that is sort of extra activity above basal metabolic rate.
So on that trial you mentioned, you said about 7,000 pounds or about 3,000 kilos or 3 tons, just of the difference in feed costs. And if you put a fairly conservative value of $200 a ton on that, on the feed cost, you're looking at $600 difference for exactly the same amount of growth and productivity. And that's on a single animal. And if you go back to the 90 odd million animals across the country and you've got that much variation, there's a lot of money slipping through the fingers of a lot of producers because of that inefficiency.
Absolutely. And if you make the wrong decision, those animals are often in the herd for 10 productive years if it's a cow. And if you make that wrong choice, it's $600 a year, but it's for that entire lifetime. And so, in the beef industry, those animals are around for a long time, and so these decisions have long consequences. And we are just starting. It's only been for the last 20 years that we've had tools to really be able to uh, really at scale and in a reasonable way get at individual intakes. And so it has the potential to be a real boost for the industry. In fact, a couple of years ago, I was at NCBA and I had a grant project at that time to try and help understand producers' decision-making process, particularly for replacement females. And one of the questions we would ask them is, how much do your females eat? How do you assess input costs in deciding which females to keep? And they said, well, we don't have a tool that does that, and so we don't pay attention to it. But with one simple decision, a lot of the metrics can look the same, but that one simple decision could cost them $600 a year for 10 years. That's a lot of investment that has gone in the wrong direction. It doesn't have any payoff. And so it has tremendous potential as we start to go from the laboratory to the field to help producers find ways to become much more resource efficient in their operations. And much like any other industry, look for places where there's costs that can be contained to improve profitability and therefore sustainability.
So I guess what I'm thinking is the scenario if we understand this, manage for it, and have solutions so that the animals are efficient and what that may look like. And I guess if we don't manage it, and what that would look like. Is that something you've worked through in terms of what those two scenarios would look like?
Well, if we're not evaluating and managing it, we're going to stay where we are. And if you look at something like the poultry industry, where they've had the ability to measure feed efficiency for a long time, and put significant pressure on it, they've dramatically improved feed efficiency, and they know that improving feed conversion ratio, which is the metric they use to measure feed efficiency, by 1,000th of a point, it means millions of dollars for their industry. And we just have not put the kind of pressure we could on that in the beef industry. But the tools are coming, that they've either come recently or are coming to allow producers to pay attention to that and have real impact on their selection decisions and what that means for the sustainability of their operation. We've been talking about feed efficiency, but the other thing, since we measure individual water intake as well, water use efficiency is another thing that has an impact, particularly in those parts of the country where water resources are limited, which you think of things west of the Mississippi as kind of a boundary. And water is a much more important deal than it is here in the Mid-Atlantic region. And I have a similar data slide that, you know, two bulls in the same test that had similar levels of performance, but the one that drank the most and drank the least, if you annualize their difference in water intake, it was 1,500 gallons. And again, you start amplifying that by the number of animals, even in a population. And in those parts of the country where producers haul water to animals, um, it's not just the volume of the water, which is a critical resource, but it's the time and labor and fuel associated with hauling all that extra water around. And so there's just tremendous opportunity in the beef industry, that didn't exist 25 years ago, to really collect data about phenotypes that can make a huge difference in the profitability of operations, and start to use that data to improve both individual producer operations and the efficiency of the industry, broadly read.
And what's needed to accelerate progress? Because you know, adding on to what you've just said, if beef prices are going up, there's a shortage of cows packing, how packers are closing down because they can't get enough animals coming through. Global demand for protein is continuing to rise and the impacts of our livestock production systems are continuing to be politically volatile and also have significant impacts on the environment. So having systems where we can produce more food with fewer resources, with less waste, so there's greater profits for those people who are doing the work and that's their livelihood, and also a lower climate impact. There's no losers in that scenario. It's a win for everyone. So what do we need, or what's needed to accelerate progress in this space?
I think the biggest thing is the ability to move technology from the research space to the industry large red. So right now in West Virginia, we've taken our technology, and for the last 3 years, we've conducted a grazing performance test for our heifers, and use that information to try and identify the most efficient in the group. Taking that kind of approach, and spreading it across the country so it's available, especially at a time that everybody talks about the tremendous need to um, grow the cow herd. Now the data about harvest suggests that people aren't retaining heifers at the rate we really need them to, but it's an opportune time from a at least a potential to grow that heifer crop and regrow the cow herd with a very, very different footprint that's much smaller than it has been in the past, that could rapidly have a positive impact on the industry, because addressing those that the shortage in females that exist today, if we could bring in sort of the next generation of females at 10 or 15% more efficient than the average of the current herd, that would have long-term impact on the beef industry, reducing footprints and increasing the potential for profitability on farms.
So you mentioned back to the motor vehicle analogies because I think they're quite useful. You've got, you're driving down the freeway and there's one car that is particularly polluting and there's smoke coming out of it and there are hundreds and hundreds of other cars, but that one car that's really, really bad has a disproportionate impact on the pollution of all the cars. And if you just get rid of that one car, then the whole freeway and the air, it doesn't make it perfect, it doesn't turn it into wilderness, but it certainly has a disproportionate effect. And those top most inefficient animals, are they similar to that highly polluting car?
Yeah, and the yeah, I have a conversation that I think is what you're getting at with my farm manager all the time. He says, if we could just get rid of the bottom 25%, it would raise the average efficiency tremendously. I tell him that, in my animal genetics class, that was selecting the top 75%. But either way, it gets you to the same place. We could make a huge leap forward. The analogy I use when I'm talking to classes is the car analogy. And so when I turned 16, uh, my parents gave me the opportunity to buy their old Pontiac Catalina station wagon, built in 1977, and it got 6.5, 7 miles a gallon. And just the cost that was invested in fuel over the lifetime of that vehicle, I could have bought several vehicles that were, had an efficiency like we have today. My son, when he turned 16, ended up with a Toyota RAV4 that gets 30 miles a gallon. I mean, it's just that's a tremendous difference in what it takes to move that down the road. And I think that's really where there's a huge opportunity. In class, we always tell students in animal science that 70% of their variable cost of production is feed cost. It's sometimes hard to really capture that value in animals that graze, because it's sometimes hard to put a value on pasture forage, but it's still a real cost. And so, at a time that margins are thin, even though prices are high, um, the ability to increase stocking density on the same acreage or maintain a stocking rate on a smaller acreage really has the potential to make a difference. When the GrowSafe tool first became available, there was a producer that got on board out in the West, and he went from stocking 19 cow-calf pairs per section to 38 cow-calf pairs per section, just by focusing on efficiency. Now, there was a tremendous focus on efficiency, and anytime you focus on one trait, that means you take away some focus from other traits. But it's that kind of improvement that's possible, and it's something we haven't put a lot of pressure on, unlike the poultry and swine industries that have had these kinds of records for a long time. We've often evaluated groups of animals and assumed they're all reflective of the average. And what I can tell you is, when you get individual data about a group of animals in a pen, very few of them are average. They're often either way out on one end, that 7 miles per gallon car, or they're at the other end and they're the 30 mile per gallon car. And selecting those efficient animals just is you have to still consider performance and fertility and production. But if you have information about efficiency as well, and you can put that into your matrix of selection, all of a sudden you can say, okay, well, for these two animals that are similar otherwise, I want to take the one that does it for less inputs. And they come in all different shapes and sizes, right? Some people think, oh, well, if they're efficient, they're probably small animals that eat a little bit. And what I can tell you is every set of data I look at for a group of animals, there are efficient animals throughout the intake spectrum and throughout the weight spectrum. And so there are large animals that are very efficient. There are also small animals that eat little but do it inefficiently. So at the end of the day, you can't find them by just looking at the animals. You got to have data about individual performance, and it's really, the one of the things that I think will come to the industry in time is we'll get away from trying to manage averages and we'll get better at managing individuals. Because even if you've got that inefficient vehicle, you can do things about how you manage that vehicle and use that vehicle and drive that vehicle that makes best use of whatever type of performance it has. And so I think there's a lot of potential out there.
You mentioned having the tools to actually get the data so you can, make these decisions and evaluate them, which is obviously critical. But you also said that that's an area that tools are emerging and it's being addressed. What other areas need additional energy focus investment? Is there policy issues? Is there market signals? Are there other areas that we need to also focus above and beyond the development of the technology?
I mean, I think the market signals, the conversations that you have with um, thought leaders at places like NCBA and others, there's this tremendous need to try to grow the cow herd. It is the although it's leading to high prices for parts of the market, those high prices are causing uh, undesirable consequences in other parts of the industry. And so, if there was incentive to grow the cow herd, to retain heifers, and if that could be done, especially to using tools that would allow us to grow the cow herd by retaining heifers that were of um, improved potential for the industry, that would be a boon. And there's discussion about how do you incentivize that in a world where heifer going to the feedlot is just worth so much. It's hard for a producer to want to retain that animal as part of the breeding herd. And so I think that is probably one of our biggest things. That what are the incentives that would lead the industry to really increase the number of heifers that were retained so that we could grow the cow herd, especially in a world where, with New World screwworm moving north, we've limited or stopped importation of cattle from Mexico. And so that's having impacts on the price of beef in the retail case at grocery stores in the US. And so there are other factors outside of sort of our normal production system um, traits that are having impacts on prices that really get at what is the cost of protein to consumers in the marketplace. And that's, anything we can do to drive those prices down is helpful for, people meeting their dietary requirements, us having the capacity to uh, uh, adequately feed particularly fragile populations. I mean, there's just a whole host of downstream impacts that would happen if we could start to um, grow the cow herd and do that in a way that addresses the demand that is out there with supply that is needed.
We've focused almost exclusively so far on the United States, but cows being cows, they're not that different here than they are across the rest of the globe. There are there's more animals in feed yards here than anywhere else, so those percentage out on pasture is even higher when you start looking at Latin America and Asia and Africa and Europe and Australia. So where do you see the work that you're doing translating more broadly globally?
I think it varies with a lot of those different places and kind of where they are in their beef cattle industry journey. So some of those places, I think of Brazil or Australia, uh, the selection of animals to perform at a high level in those countries is um, it's similar, I would say, to ours. I have not been to those places, but in what I read and in conversations I have with people, they're much closer to ours. There are also places where, you know, live animal is the primary determinant, and so there's because there hasn't been a lot of selection pressure on, productivity or efficiency, there's tremendous opportunity. I think there's a need to be sensitive to, the cattle that perform in Central Africa are have a different genetic base than cattle that perform, in the northern reaches of Canada and Russia. And so, it needs to be place-based, but I think there's huge opportunity for aspects of precision livestock farming and US, Europe, Australia, Brazil, those kinds of places will adopt technology the fastest, but sort of older generation, but still recently developed technologies could have a tremendous impact in places where there hasn't been as much advancement of the industry for the genetics that exist in those places. And so it's something I think that there's a tremendous opportunity globally for us to take the land that's available. And the reality is across the globe, the greatest proportion of agricultural land is grasslands. We often think of, or at least my perception of the common thought is, you talk about agriculture and people think about row crops and tillable land. But the reality is the greatest proportion of land globally is grassland that could be used for grazing, where ruminants are well suited to convert those grasses into that are mostly carbohydrate into high quality protein for human consumption. And so I think there's just tremendous need to look for ways to transfer technology at an appropriate stage. Maybe here individual animal performance testing is the key, but maybe in some places just knowing better what performance metrics are would be helpful in identifying animals that could do more with less. I think at the end of the day, that's the real key. We've got no more land that's going to become agricultural land. We've got good quality agricultural land that's being removed from production all the time, all over the globe. And so how do we try to do more with less as populations continue to grow, populations continue to move up in from sort of third world conditions to second and first world conditions. A lot of things we worry about in third world countries are dietary, right? There's an awful lot of preventable disease and suffering that occurs just because of malnutrition, which is sometimes undernutrition. Sometimes it's just not the right blend of nutrition. And so there's tremendous opportunity for animal agriculture to upcycle poor quality feedstuffs into high quality protein for human consumption. And I think there's uh, it's reasonable that those of us that are at the leading edge of that find ways to take things that are applicable to populations and apply them in their culturally appropriate ways.
I think it's probably also worth adding that somewhere in the order of 1.5 billion people globally rely on livestock and livestock production for their livelihoods, which is probably bigger than any other single industry. And those millions of square miles or square kilometers of land that are used for livestock production. If we, as humans or as societies, want to impact that land, the most powerful avenue to do that is through those people that are currently the custodians of that land, which are the herders, the farmers, the ranchers, the pastoralists, wherever that happens to be in the world.
Absolutely. I think that's really critical is that, you know, being able to help communities, villages, whatever the appropriate unit of society is, to be to attain a better standard of life for them and their families. For those that agriculture is their calling, finding ways to improve how they do it in their systems is a value to them and their family. Just like any other industry that we can improve the productivity of has value for those that are involved in producing.
You mentioned perception earlier on, and perception is one of those things that's very, very individual and personal. So I'm certainly not going to speak for humanity in this perspective because I wouldn't be so bold. However, frequently in conversations when it comes up about the beef industry, the picture that people get are the big feed yards.
Right.
Um, and 12% in the US, much lower elsewhere in the world, and the grazing systems are where the animals are. Is perception and people's perception an issue that we need to spend more time and effort on? And if you think that is the case, what do you think are the priorities there?
It's something that I actually think a lot about. The message about what we actually do in agriculture to feed populations, in the US, less than 2% of the population is engaged in agriculture in any way. Uh, it's kind of funny you ask because just yesterday, one of my sons, he's a freshman in engineering at WVU now, he sent me a reel from Instagram, and it was some guy talking about beef production around the world and the what I think is an artificial dichotomy of grass-fed versus grain-fed. And he stated with great assurance that grass-fed cattle take 18 months to mature, and that corn-fed or grain-fed animals take 6 weeks. And my son, who's only kind of partially paid attention over the years, says, "Dad, we don't even wean the calves when they're 6 weeks old." But it's just, there is all because there is so much information out there in our modern world, and and information literacy and information reality are huge struggles. And I think there's an opportunity for those of us that are involved in agriculture to do more to help people understand what really goes on. Um, I didn't come from an agricultural background. My parents live in a city in Indianapolis. And so when I talk to them, I always try and, I try to be as objective as possible, which I am a person that's engaged in the industry. And so I have a certain perspective sometimes, but trying to help them understand the realities of what does it take to feed, 8 billion people. Where are they? Where are the resources? How do we do that? How do we actually get from a calf on the farm or a lamb or a kid, if it's a goat, to an animal that's ready to harvest? What does that really look like? What are the footprints of it? How do they compare to other plant-based protein sources? Um, you know, there's a whole um, need for translation of what is sometimes very technical scientific information to general audience. When my boys were very young, uh, they asked the quote unquote teachers at their daycare before they were in kindergarten asked me to come and talk to the kids about animals. And so I came in, I put diapers on a couple of lambs and brought in some 3 or 4 day old chicks so they could have something to see. And it turned out the word got out, and a bunch of moms came that day too, which was a little odd to have all the moms present at daycare. Um, but there was a kid that showed up with a super deluxe hamburger on the front of his shirt. I didn't stage it, but it was perfect. So I brought that kid up front and we just started the topics, where's the bun come from? And then all the kids said the grocery store, those kinds of things. And we eventually got to the bun comes from the farm and the lettuce comes from the farm, and the hamburger comes from the farm. Uh, and and so by the end, I got the kids. They understood that when I said, "Where's the food come from?" They said it comes from the farm. And one of the mothers raised her hand and she said, "But not candy." And I said, "Actually, candy comes from the farm too." Um, and I oversimplified it. I didn't talk about wild caught seafood, and there are some non-farm food products, but it's that notion that it all has to come from the farm, that it's a huge complex. The notion that there's something like 3 days supply of chicken in the US at any given time. And if we stopped producing and harvesting it, it would disappear like that. And people just don't think about what it takes, what has to happen in some cases 2 years ago to get food on their plate, whether that's at home or in a restaurant or in an institution. It's a huge complex thing, and there's all kinds of pricing signals and other things that impact how the people that do that production make decisions about what they're going to produce. And those are stories that there's not enough general understanding of. And so, you know, I recognize there's a limit to how much I can do about it, but I take every opportunity I can to talk to general audiences and help them start to understand, you know, for something that we depend on daily, it's a big deal. I spent a little time as the associate dean for research here at WVU in the ag school, and I would talk to one of the vice presidents of research, and she would often talk about the great research that was happening in the physics department and the great research that was happening in the medical school. And over time, I worked on her and I pointed out, I said, there that most of the world's population may never ever in their life see a doctor, but almost all the population has to eat. And it's just, you know, it's a different calling to be a researcher in agriculture. It's a different calling for those people that work in production agriculture. And they don't get the credit and the thanks that they ought to, because especially in first world nations like the US, we've got so many choices that we don't know what to do about it. And the thing maybe we shouldn't get into, but I'll mention it, is that, no matter how efficient production is, uh, the amount of food we waste is another side of the bigger agriculture food system uh, continuum. And in the U.S., 40 to 50% of the edible food that is produced is thrown out. Um, and I spent some time trying to get anaerobic digestion or other tools for making higher use of that organic waste. Ultimately, we were unsuccessful, but you would have conversations with people, and they just were completely unaware that most of that goes in a landfill and rots away, and creates um, detriment to the ecosystem by being rotting food. And so uh, it's a big issue. And I think the we don't worry about food because it's plentiful here. We focus in the US more on excess calorie intake, and it is a problem in the U.S. Obesity is a real issue in the U.S., but in most of the world, in the sort of average human, they've got insufficient calories, or at least insufficiently balanced calories. And so it's a hard thing to get people to wrap their mind around, and understandably, but we need to talk more about it, no doubt.
Think back to the animal side of things when you think of pre-industrial revolution societies. Animals were that food recycling mechanism. Anything that wasn't eaten in the house was fed to some chickens or some swine or some sheep or goats or cows and converted back into something that was then edible. Plus, you've got the nutrient cycling through their manure and through their dung going back into soils or vegetable gardens or all those sorts of interactions and that feedback loop has been fairly dramatically severed in our modern societies.
It's been partially severed. Uh, I one of the things I sometimes talk to people about is, if you think about food processing, there's a tremendous amount of food processing, what we used to call byproduct, and sometimes we call it now co-product, but components of converting raw materials into further processed food stuff for consumption, that there are products there that today the 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 those things go into animal diets somewhere. Whether it's the starting in the 90s when we started to make a lot of ethanol, there's there was all of a sudden all these waste products from that ethanol production, we call them distillers grains, that there was a need at the time for in the 90s for research on how do those become good feedstuffs, because just burying them or landfilling them was too costly, or not the right thing for those industries to do. And so there's a lot of cakes and meals and other, in animal agriculture, we talk about soybean meal as a ingredient all the time. And soybean meal is the waste product of soybean oil production. And, it's a fundamental component, particularly of monogastric diets, like pigs and poultry. And so there's still a lot of that happens, but it's not in a defined, you know, watershed level ecological circle, right? Those things are moved across the country, and so the co-products and the things like manures and other things end up in disparate places. If you look at a map of nitrogen flow across the globe, there's these huge arrows of nitrogen exiting the upper Midwest of the US, going to all kinds of places. It's not staying in a circular economy there, uh, in the upper Midwest. And, there's implications of that, and um, it's a it's a complex thing. And I often tell people that I don't like to talk about systems. I like to talk about complexes. It's like a big bowl of jello. And if you push it in one place, what you get is a reverberation of consequences. And so, if we sometimes try to come to simple solutions to a perceived problem without recognizing that adding or removing something from the complex doesn't just address that thing, but it then has these follow-on consequential reverberations to all kinds of other aspects. And so, it is, the deeper you dig into it, the more complicated it gets. And so I sometimes have conversations with students, have had some of our classes, they hear about an issue and they say, well, we should just not do this, or we should just not do that. And then you start thinking about, well, here's what other activities depend on, step one. And you don't often think about that. And so, if you change this operation, it will impact other places. And sometimes those impacts are as detrimental or more detrimental than the problem you're trying to solve. And so, you know, helping young people as they grow and develop to recognize that interrelation of food and agriculture, and then the food and agriculture with larger things in the world, um, and both the sort of biological processes that are impacted. And then you layer on top of that policy, and sometimes well-meant policy, but that has just um, tremendously constraining consequences that then then lead to other unintended and sometimes not recognized for some period of time consequences. And so there's a lot to do. There's real opportunities to improve things. And, circling back to your comment early on, improving the efficiency of the beef industry or animal agriculture, more largely, um, it has win-win consequences. And it's sometimes hard to find those things that are a win that lead to another win. And so I think it's important that um, that be part of education, be part of communication, and it's something that agriculture has historically not done a good job of telling its story, especially as fewer and fewer people were involved in it because it was no longer that diversified operation that had some cows, some pigs, some chickens, and the slop went out in the yard.
Well, that's 100% why I invited you on today to discuss this because the work you're doing across that feed efficiency side of things is such an opportunity to create that win for farmers and ranchers, that win for food productivity and food security, and also that win for the environment and climate. And they're few and far, but well, not few and far between. When we find them, we need to make sure that they're lifted to the top and put on the agenda and discussed, so they don't slip through the cracks.
Yep, I agree 100%.
So, before we go, is there anything else that you'd like to add that we haven't already discussed?
Um, I mean, I think we've we've covered an awful lot of ground. I think the biggest thing is how do we do a better job in our industry? How do we do a better job of communicating what we do for the globe from our industry and helping people, especially outside of agriculture specifically or science generally, understand, you know, what is really happening, what could happen, and how to make good policy. Because at the end of the day, all of these things, the hardest part of them is the human dimensions piece. I'm convinced of that. I mean, I can tell students to study for class, and getting them to do it is the hard part. I can talk to producers about changing management practices for the financial benefit of their operation, but getting them to do it's hard, and that's the real part. And I'm not a anthropologist or sociologist or psychologist, but I have over my years come to realize that human dimension piece is the hardest part of all this.
Matt, thank you so very much for joining me today.
Sure thing. Thanks for having me.
Thank you for listening to the Ash Cloud. Please subscribe to Ash Cloud if you've enjoyed this podcast, where I will continue to discuss food sustainability with guests who bring a deep understanding of the environmental, political, and cultural challenges facing our society and creative ideas on how to address them.